Hello everyone. This is the second module where we continue to talk about developing web applications from scratch. I'm going to start from where I left off. If you haven't seen the first module, please look at the list where I'm putting all these videos, and it's a quick introduction and a little bit of history why we're learning web applications and how we can start our first simple web applications. So today I want to talk about one of the most important. We said there are three parts of an MVC applications: model, view, and a controller. And that paradigm or that architecture is very effective. It makes sure that things are as separate as possible and as pluggable as possible. So when you want to change your module or you want to change your view, you don't have, it's not spaghetti code, meaning that it doesn't affect other parts of the system. So today we want to talk about models. And models is basically a presentation of something that you're trying to mimic in the real world. Meaning that, let's say there's a store that sells cups, just simple cups like these, and you want to build a system that manages the sales, that keeps track of the storage, of the, how many cups you have, all the commercial activity within that cup, within that store for these cups. And you want to build a system. So the first thing you want to think about when you want to build a web application is what models represent that system. So when you look at a store that sells cups, you could think of, the first thing we could think about is a cup. What do we need out of that model that will help us represent the problem that we're trying to solve for that store? So if the store just needs to keep track of the cups, so we want to keep the cups that they sell or bring in, so we just simply want to keep track of how many cups we have. We don't care about their color, we don't care about their weight, we don't care about their shape. You're trying to make your model as simple and as small as possible within your system. There is a big theory behind this, and I'm going to get a little bit of academic here for a second, but then I'm going to bring us back to the real world applications. There's a theory behind this. Whenever you try to solve a problem in the real world, you just want to extract the minimum possible variables out of this world that you're trying to solve a problem for, and then build your system on your computer based on that. Meaning that, for the store that sells cups, we don't have to worry about details that doesn't help in any way, shape, or form solving our problem. Okay, let's take it up a notch. So we're building a model for these cups, but in addition to the fact that we care about how many cups we have, we also want to know what kinds of cups we have. So now we got a little bit, in more detail. So let's represent that in our ASP.NET MVC application. I'm going to go to the models, and previously, as I said, once you start an ASP.NET MVC application, it puts together all of these folders for you. And I told you, like, some of these folders are just as important as the others, but the main things that we want to focus on before we worry about anything else is controllers, models, and views. So we just from an organization perspective, you could build your model literally anywhere in the system, but you want to have your solution maintainable, meaning that if some other programmers came in and wanted to contribute to your application, it should make sense to them based on some global standard, universal standard that people agreed on. And for someone who knows what is ASP.NET MVC, it is obvious that the first thing they're going to do, they're either going to look at a project that looks like this, that just contains all these models, or they are going to directly look at the folder that refers to the models. So you want to make sure that all your models live in that folder. Also for yourself, you know, a lot of people say you want to make your application readable for other people. So what if there are no other people that are going to contribute to that project? You are the whole team, and you're the only person that you speculate that will be maintaining that project. When you leave a project for a while and then you come back to it, you will not remember what you were doing there unless your code follows some standard. It doesn't matter X or Y or Z standard. Make up your own standard and just be consistent across all your projects so you could maintain them. So let's build a model for a store that buys and sells cups. So let's go here and say I want to build, right click, add, and then I want to build a class. Models are just classes. Again, if you want to learn what a class is and all that, then maybe this course is a little bit advanced. Go back and learn the basics of C# and programming, and then come back to this. So let's say a cup. All right. So we have a class here. We called it a cup, and that's our model. The first thing you want to care about is to maintain some unique identifier for these items. And unique identifiers are important because if you want to track an item that was lost, an item that was broken, an item that needs to be returned, you want to keep track of all these items with some serial number, with some GUID, GUID stands for a general unique identifier, something that is very unique and generic that will, makes your item very distinguishably different than any other items on the system. So some people go with GUIDs, so they just go here and say, I'm gonna write it first, like the class member, as like handwritten, but then I'm gonna tell you about a shortcut that just writes it on for you. I'm not gonna use my Visual Studio foo yet. So here we're defining a public, and then here's my type, and then I'm just gonna say my ID. I'm just gonna set my setters and getters. So that is a first member that uniquely makes this one cup different than the other. Well, cool. How do you do that real quick? For productivity, just type in prop and tap twice. That's it. Let's try that again. Oops. So I don't want all that. I'm just gonna go and say prop, and then tap, and then another tap. Okay, you created your thing, and then you want to jump in through things. As you see, the things that can be changed when you're defining a class member is the type, the property type, and the property name. So you can jump between by also clicking tab. So that's how you change things. So we're just going to give it a GUID name, and we are going to call it ID. Now, you build the ID. What else do we want to know about this cup? We said our problem is that we want to keep track of cups by type. So we want to build some type for each and every cup. Some people may go and say, okay, then we're gonna just type in a string, and then we're gonna say type. And that is a can of worms. Why? Because every time someone is going to insert the type in the system, so people are going to be building your models and whatnot, so people are going to be starting to insert some information. Some people may type, let's say, German cup. And some people will say German. And some people will say German lowercase. So it doesn't give some consistency to a bunch of things that share the same type. So we want to change that. We want to control that. So instead of building the type as a string, why don't we create an enumeration that will allow us to control the types that are entered for a certain cup? So let's go and build a, let's see, again the same thing. See what I did there? I just typed in enum and tap, and it built my enum for me. But I want my enum to be public, and I want to call my enum cup cup type. So let's give our cups a bunch of types. So there are Chinese, there's German, made in Germany or something. There is USA, Germany, and let's say, what else? Mexico. So now, instead of having people, making up their own types and whatnot, you're putting in some control in there. And we can get a little bit deep into how to allow others to add in their own types. But what we care about now is to build our type in a way that we can use in the controller and the view. So so now we used to say a string. Now we're going to define our cup with this enum. So now when we go ahead, this is just a pseudocode. If I just say we have a function here, some function, and we want to instantiate a cup, you could go and say for the type, once you say equal, it will pop up the enumeration, and you get to choose what kind of cup we want to keep control of, like the type that we want to have this cup defined as. All right, so that's building models. Why building models is the most important part of an ASP.NET MVC application. The models are the entities that live within your system that gives your system a characteristic. They're like the skeleton of the human body. These entities or these models or these classes, they have 100 names. These models represent where actions begin and also what may actions end. Meaning that these models are the core of your system. Based on these models, your system is decided to do something that you're trying to achieve. So you want to pay a really good attention when you're trying to read through a system requirement. You want to know exactly how to extract a model. So let's see how we can extract a model. I'm going to type in real quick a requirement. Build a system that allows store employees to control what cups they sell and what cups they need to order for customers. Here's a simple requirement. How do we extract our models from a requirement like this? The first thing you want to do, look at the nouns in your requirement. Let's just gather the nouns, that's all. So let's see what are the nouns in here. System, store, employees, cups, customers, right? These are nouns. Great. So based on these nouns, we have 1, 2, 3, 4 models. Now, let's filter these nouns so we only need the models that we care about. The system is out of question because that's what we're building. We have store, we have employees, we have cups, and we have customers. So within a system, we want to build a bunch of models that will interact with one another to make that system works. So the first thing we built in here are cups, right? The second thing we want to build is the employees. Let's build another model in here. What do we care about? Why do we want to add employees? We want to know who is the person that made the purchase, like authorized selling one cup or the other. So the same thing, we're going to give it an ID. We may want to know the name. And that's pretty much it. We don't really care anymore. So these are the employees. So this is done, and this is done. Okay. Now, you have customers that come in and pay and whatnot, pay money to buy stuff. Some mistake may have happened in the store, and you want to contact these customers. You probably have rewards program, or you have some offers, or things are on sale and whatnot. So let's keep track of our own customers as well. When you say customers, that's plural. We want to only put one and then go from there. So we have a customer, give it an ID, give it a name. Good enough, right? What else do we need? So this is done. The store, I don't think we need to do anything with the store, but there's something here. We need to keep track of the orders. So let's build orders as well. Done. Oh, still in progress. So let's build orders. Order is basically a model that combines two models' interactions. It represents, it's not real, it's not a cup or a customer or a client, but it's a model that represents a certain action that happened at a certain point. So let's keep track of that, only if we want to keep track of it, and probably we do. So here's what we want to do. Here's an order, right? Here's what we want to do. We're going to give it an ID. So every order is unique. We also want to give it a date. So let's say date, time. Right? We also want to say who is the person that authorized that purchase. So that's going to be an employee. And then to what customer did we authorize that? So we want to say customer. What else we want to do? We want to keep track of what cup this customer have bought. So let's go and say cup. That concludes a whole interaction that happened within a system. So you keep track of customers, you have a bunch of customers, and you have a bunch of, did I not call it customer in here? Oops, sorry. Here. So you have a bunch of customers, and you have a bunch of employees, and you have a bunch of cups. And you want to link all these together. So when you go back, you want to keep track of your orders and you want to execute some functionality. So that's it. That's all we care about. We have a system that allows us here to, we have a bunch of models in here that allow us to see how our system functions. There is a nifty feature in Visual Studio. It's called Code Map. And what Code Map does, it makes you visualize the models that you have on your system. Now, some models we don't really care about, and some models we really want to keep track of. So let's go down there and let's see how is that visualization is happening. Taking a little bit of time, almost out there. Okay, here. So we have demo.models, and the model that we really care, the bunch of models that we really care about is order, customer, cup, and employee. See how the order is referencing these employees. I don't want you to worry about any of that. I just want you to worry about that part. So the order here puts the customer, the cup, the employee in one bucket, in one model, and it allows you to keep track of that action that happened at a certain point in time in your store. Of course, there are even like more complicated interactions, like you could add to your order, you know, cancellation, returns, you know, here's one really nifty part that we want to keep track of. You also want to keep track of the item price. Okay, so if you want to standardize your prices, you could link the price to the type, and if you make up cups by hand, then you get to actually make the price however you want. I recommend, if you want to do money, then use double, because that will help you later to support fractions like $12.50, stuff like that. If you put in an integer in there, that won't be very helpful. So that's that. You have the price, you have the type, you have the ID. That's how you know, it's this part of the system is the most crucial part. I mean, all other parts are pretty important, but if you don't have a good visualization of the real world that you're trying to build a system for, you won't be able to move forward with your system, and that's a very important piece. So what I want you to do as an assignment, go ahead and try to think of a system. Do not do the cop store. Don't do that one. Do a system on your own. Look around you. You know, maybe you're selling monitors or you're selling electronics in general, and you have all these types. You have a monitor type, you have a TV type, you have, you know, gaming console type. Try to build, just don't worry about how to use these models. Just worry about how you could look at a given problem, and that's in computer science, it's called problems, meaning that there is a need for something to solve an issue. That's why they say software solutions. These solve a problem, right? We use Windows or Linux or Mac. It's an operating system that helps us, you know, solve something, send emails. We have a problem. I want to send an email. That's my problem. And I need an operating system to start my computer so I can log into my email service and just send emails and so on, stuff like that. So a good software engineer will look at a certain system and be able to extract the models that make sense. And out of these models, like for the cup, we don't care about the cup weight. So we don't want to care about that. We don't want to include that in our model. It's there, But there are 100,000 variables in our surrounding environment that'll take forever for you to put them all in there. You know, the temperature of the cup. Why do we care about that? We don't care about the temperature of the cup. The width, the height, the what's the cup is made out of. Don't worry about that. If your system does not care about that, then you don't want to worry about that. So that comes from focusing on what the problem is. In this particular case, in this particular project that I'm trying to build in here, it's very obvious that it says to control what cups they sell and what cups they need to order for customers. That's your problem. So we know how to extract, today we learned how to extract models out of our system. And here's the thing. When you take a requirement from someone, you have to write it on paper and just sit back and look at it and try to understand what you need to extract out of that requirement. And if you don't know how to extract that out of a requirement, the solution is very simple. Just look for the nouns. Look for the nouns in your system, in the requirement, and pick them up, and then ask yourself that question: do I need to build a model for that noun? So before that, we had system and we had store. If we have multiple stores, yeah, it makes sense that we go in and build a model for a store so we can keep track of what store have how many cups with what employees and all that kind of complications. But in this particular case, we don't care about that because we have only one store. So you're building one system for one store that has orders, employees, cups, and customers. So give it a shot, and thank you for watching. See you next week.